Hello there. All right, Miss Harper here, wanting to go over this exciting quadratics test review. All right, so this first chunk, vocab, I'm not going to spend a ton of time in this, but let's remember real quick our vertex. Our vertex, remember that's like your maximum or your minimum point. So it might look something like this on a graph, and it's this point right here. We also call that the point of transition, and again, we sometimes refer to it as well as our maximum or our minimum. A positive quadratic, we all know what that looks like. That's going to open upwards. Remember, he makes a little smiley face. Our zeros, remember, those are the rocks. That stands for our roots, zeros, x-intercepts, and solutions. And ultimately, all of those things talk about where our graphs are crossing our x-axis. So that would be right here and right here, if any. Remember, sometimes he doesn't cross the x-axis, and sometimes he just barely touches it in one place. So there's all those different things. Roots, again, those are part of the rocks. Same thing. Ultimately, it's where he crosses our our x-axis. The y-intercept, well, this is actually where a graph crosses the y-axis, okay? So we might have something where he intersects our y-axis, like right there. Our maximum, this comes on our graphs that are negative. It's the highest point. It's also a way that we describe our vertex. The minimum, this only comes on positive parabolas. And again, it's our vertex or the lowest point. Solutions, those again, rocks. Remember, they will try to call it all sorts of different things. They will call it roots, they will call it zeros, they will call it x-intercepts, they will call it solutions. Ultimately, those all mean where he crosses the x-axis. Our quadratic parent function, remember this one is y equals x squared. He's the OG of parabolas, I guess you could say, or the OG of quadratics. He is just the most basic function of our quadratics, and he is y equals x squared. And then our negative quadratic, these are the ones that open up down, they open down, and they make a sad face as well. Now, I went through very briefly, but you will want to go through and actually write out using your own words what the definition is for each of these things. So make sure that you do take the time to write down a couple quick words to help you remember what those things are. All right, let's check out this part 2. Part 2, which quadratic equation best represents the parabola shown below? All right, so on this one we have a couple different options. One great option would be to just go in and plug in each of these equations and go see which one mostly looks like that guy. But we can make a couple assumptions right off the bat. Looking at this guy, is this a positive or a negative graph? And he is negative. See his little sad face over there? So we for sure know that our x squared is going to be negative, so we can eliminate those two. And then from here, I can also see that he shifts up 5 units, and both of these reflect a shift up 5 units. I don't know what this little x right here is going to do, so I'm going to go ahead and open up my calculator, go to y equals, and I'm going to plug these guys in. I have negative x squared plus 5, and I'm going to plug in this other guy, negative x squared plus x plus 5. And I want to go look at their graphs. So there goes the first one. He looks pretty similar. And then I see another guy. So he's off-centered and shifted just a little bit. So I want to go back and look. So both of these are kind of close to me. It'd be hard to see. But one thing I do see is right up here, I see my vertex, and it's at 0, 5. So what I want to go do is go look at my table and see who has the point 0, 5. Oh, they both do. Even better. All right, so they both have the vertex 0, 5, so what I want to do now is make a little XY table and see who has all the points that I'm looking for. So I see another nice little intersection right here, so we have 0, 5, and I also have negative 2, 1, and I also have positive 2, 1. So now I'm going to go look again at my table and see who has all of those points. So see if I can move this over a little bit. All right, so looking at my table, I see 0.21 on my first graph, but not on the second graph. So that means that the red one that we were looking at, the second one, he's actually going to be out of the game at this point, and we're going to be left with C here. So again, a great strategy here is to go pick a couple points. If they're really close graphs like we were just seeing between these two, pick out some points, plot them, and then go see which table has those points on there, okay? Let's check out number 2. Whoa, a quadratic function is given, f of x equals 3x squared minus x plus 6. What is f of 2? All right, so if you remember these guys, what I would always tell my classes, I would say, well, what is that 2 replacing? And we would say, oh, well, that's replacing the x that was right here. So that means that tells me I'm going to plug that 2 in for my x. So I will have y equals 3. Now again, I'm replacing the x with the 2 minus 2 plus 6. I could do this manually if I wanted to, or if I didn't feel like doing that, or I just wanted to double check myself, I could also go to my y equals function, plug this in. So let me clear these guys. I could go here. We have 3x squared minus x plus 6. And go look at my table. And I want to see what is it when x equals 2, and I see that right here. When x is 2, my y value is 16, okay? And again, I can double check this really quick too, because we're smart and we're able to do math. 2 squared is 4. 3 times 4 is 12. 12 minus 2 plus 6. 12 minus 2 is 10. 10 plus 6 is 16, okay? So a couple ways to double check ourselves there. Excuse me. Here on number 3, which equation will produce the widest parabola when graphed? So if you remember, a whole number will make it more narrow, and a fraction will make it more wide. Okay, so I'm looking for a fraction or a decimal answer. So I'm going to eliminate choices A and B. Now, who is closer to 0? Is it negative 0.6 or is it 0.2? If you're unsure, which hopefully you can recognize which is which, but we can always plug these guys in to our calculators. So I have 0.6 x squared, and I also want to compare it to 0.2 x squared, and I'm going to go see who is the widest between these two. So there goes our negative 0.6. And here comes our 0.2, and hopefully it's obvious who is wider than the other, and that's going to be 0.2. Again, you can kind of translate these two. This is like 0.60, that's 0.20, so who's closest to 0, and that would be 0.2. He would be our widest graph. All right, looking up here at number 4, we're talking about a model rocket that they shot. So we want to see which of these statements or what conclusion we can make about this rocket. So kind of reading through these answer choices, the rocket reached its maximum height after 2.5 seconds. Well, let's see. So I'm looking at this graph. It looks like his max height or his vertex is about right there. So looking here at 2.5 seconds, that would be right here. So if I draw my line, it doesn't look like that's quite his max height. Hopefully you would agree with me there. So that's going to be a false statement. Option B says at 0 seconds, the rocket was 2 meters off the ground. So if I'm looking down here at my time, at 0 seconds, it looks like he starts about right there, which these are increasing by 1, so that would be at 2. So I'm going to say, yeah, I think that's a maybe for now, but I always want to make sure that the rest of mine, the other statements don't work too. The height of the rocket was 0 meters when it was launched. So that means at 0 seconds, it would have to be down here. Okay, well, it's looking like our graph starts a little bit above that. So I'm going to say he's a no-go as well. And then the last one says the rocket was in flight for 5 seconds. So again, looking down here at my time, Here's 5 seconds. It looks like he's coming back down to the ground, and I don't think he's going to make it out to that full 5 seconds. So I don't think he was actually in flight for that long. So it seems like my best conclusion that I can make here is that yes, the rocket was 2 meters off the ground whenever he started. All right, love number 5. Which of the following is the vertex of the graph of this equation? So, looking at this graph, let's just go ahead and plug it in. I'm going to go to y equals, and I have y equals negative x squared plus 2x plus 3. Let me get rid of this other one. All right, so let's go check out our graph, see what he looks like. And there he is. Is that a maximum or a minimum? Is my vertex a max or a min? Yes, it is a maximum. So let's go second trace. And let's find what our maximum is. Hit enter. Take my little Spider-Man. He's already sitting to the left of my vertex there. I'm going to click over here, sit to the right of my vertex, and he guesses for us, and this 0.9999999, this guy's going to round up to a 1, so I'm at the 0.14. 14 is our vertex. All right, number 6, looking at number 6, what are the solutions to the quadratic equation 2n squared equals 5n plus 7? All right, so ultimately he's asking us, again, solutions are just another word for x-intercepts. First, we have to get these things set equal to 0. So I'm going to move this stuff over here by subtracting those two things. So I have 2n squared minus 5n minus 7 equals 0. If I wanted to, I could definitely go through and factor this by hand, but a safe bet would be to go ahead and pop it into my calculator and see what we got going. So I have 2x squared minus 5x minus 7. And I'm going to go look at my graph, and from there I'm going to find my two x-intercepts, and another word we call those are our zeros. So if I go to second trace, I want to find one of my zeros. So let's find this guy over here first. So I'm going to go just above it to the left. I'm going to go down a little bit just to the right. Hit enter. And he tells me that one of my zeros is at negative 1, 0. So let me write that down over here. Negative 1, 0. And let's go figure out where our other guy is. Again, we have to do these one at a time. Trying to find my other zero. Scroll to the other side. If you have not heard my Spider-Man song yet, you're missing out, and it's really, really good. Just kidding. All right, and we get 3.5. Whoa, y negative 1e to the what? What does that mean? Hopefully you remember anytime you see this e in your calculator, what does that mean? Yes, it does mean 0. So we get the point 3.5, 0. So looking at our answer choices, I need a negative 1 and a positive 3.5, and I see that here at B. All right, number 7. Number 7, which of the following polynomial equations best represents this graph? Okay, so I could just go and plug each of these equations in if I wanted to, but I want you to pause and look at those for a second. What does that look like? What do these things over here look like? Hopefully you're thinking, well, it kind of looks like those factoring things that we were doing. So remember, I've mentioned it to you guys. What were we actually solving whenever we were solving for these factors? If you remember, we would take the factor and we would set it equal to 0, and then we would solve for that factor. X equals negative 6. So what we were doing there was actually finding the roots. Hopefully you remember that. So that's one way you could do this. Our root, this is telling me that this particular graph is going to cross the x-axis at negative 6. So you could go with it that way if you wanted to, or you could just plug these guys into your calculator and figure them out that way. Alright, so I went ahead and chunked each of those guys into my calculator and then let them graph all 4 of them at one time. So I know this screen looks a little crazy right now, but if you can look closely, this first blue one in here, the blue parabola, that's our first equation. Then we have this black one, and that's our second equation. Then we have the red was actually our second equation, black is our third equation, and then purple is the fourth equation. So looking at those, who looks most like the graph that we see right over here next door? And I am going to say that the blue guy looks most familiar, mostly like what we're looking for. So that is our first equation. And again, you can always solve it this way. So I did this run right here. If I did this x plus 2 and I set that equal to 0, I would get x equals positive 2. And so these both tell me where they cross my x-axis. Be careful, these have a little bit of a scale on them, so these are moving up by 2. So I see that when my graph crosses right here, and this is actually at -6. And then I see it crosses right here. These are all counting by 2's. This would be crossing at positive 2. So it's going to be A. C was shifted to the right just a little bit. He was crossing at positive 6 and at -2. All right, but again, just plugging these guys into your calculator is always your safest bet to see who looks most like what we're looking for. All right, and then on number 8, couple options again here. We can go through and we could factor this guy out if we wanted to. We could use the quadratic formula if we wanted to and find our roots. But ultimately, again, we just want to go in and check out our calculator. Alright, so on this one, he doesn't really tell us a lot, but those answer choices are their solution sets, or their solutions, or their roots, or their x-intercepts, or their zeros. Okay, so the question is asking us to find where are they crossing. So it's kind of hard to see right here. So I'm going to zoom in a smidge, and then I'm just going to go through and I'm going to find what my zeros are. Uh-oh, we lost one of them. I have to go find what he is. So let me go figure out what this first guy is. He's a 0 that I'm trying to find. Whoa. There he is. So we go left. Then I'm going to move up here to the right. Graph. So my first 0 comes at -3.50. -3.5, 0. Alright, and then let me find that second 0 real quick. I had to zoom out again, so I'm going to click all the way over here, move my Spider-Man to the left side of the intersection of the x-axis, to the right side, and I get -12.5, -12.50. So I did that, and I'm not seeing, whoa, all of these answer choices look super crazy. So what I need to do is actually plug these things into my calculator and go see what their decimal value is. So if I do this first one, 8 plus 2 times the square root of 5. Alright, so just plugging that into your calculator, the decimal value there is actually 12.5. So that's good to know, 12.5-ish. It's approximately equal to that. However, that's only one answer, and I clearly had 2 zeros. So because he's only one, I'm going to have to say, no, sir, you are not the one that I'm looking for. So I'm going to just keep doing this for the rest of them. I plugged in option C, and as you can tell, we actually got a negative decimal value there, so I'm going to have to eliminate option C as well. In this next part, I plugged in option B. I did 8 plus the square root of 11 and also 8 minus 2 times the square root of 11, I'm sorry. And again, I see I got 14 point something and 1 point something. Well, neither of those are the numbers that I'm looking for. And then plugging in my last 2 on option D, whenever I did -8 plus 2 square root of 5, I got -3.5-ish, and I did the other one and I got -12.5-ish as well. So that's going to go ahead, those are going to be my answers for this guy. And then another option, again, like we said before, you can also do like the quadratic formula, and I'm going to do that off to the side right here real quick if you'd like to see that. All right, so for those of you who are interested in seeing it broken down in the quadratic formula, I know some of you guys really like doing that. Here I go kind of through it really quick so you could pause and look at my work. Plugged everything in. Right here I had the square root of 80. I needed to simplify him, so I got this. And then I reduced everything by a common factor of 2. So we got that negative 8 plus or minus 2 square roots of 5. Alrighty. But don't let that freak you out if you missed that or you weren't here again. Ultimately, we just want to plug these things into our calculator. Now, don't forget about all of this stuff. Didn't really put it on the test review as much because it's just things that we've been doing really recently. You should have plenty of notes, plenty of practice assignments, and all sorts of stuff to look up. So how to find roots, remember we do this in our calculator. Second trace vertex, again max min in our calculator. Quadratic formula, as you just witnessed over here in the red. If you need me to sing you the song, I will. When the graph gets wider or narrower, so remember if we are using a whole number as that a term, so if I had like 4x squared, then that graph would actually get more narrow. If I had a fraction or a decimal like 1/3 x squared, then that guy would get wider. Remember the C, the little last number there on those things. So if I had something like y equals x squared minus 4, this guy, he determines how we move up or down on the y-axis. So that in this case, he would move down 4. And then the applications of quadratics. Those are the ones referencing where we are like kicking a football or hitting a baseball or things like that. Just finding like how high was the ball after 5 seconds? What was the max height of the ball, or how long before the ball hit the ground again? So things like that. So make sure that you go over those notes and stuff before we jump into our tests. I wish you all the luck. If you have any questions, please come see me.